We begin with the concept of definite integral as area under a curve. So here by area under a curve, we mean that we are trying to find the area between any curve and the x-axis between the two limits on x. So what it means is like this. Suppose let's consider that we are having the graph of certain function. Okay, so here let's consider some function in general, that is y is equal to f of x, and between the two limits on x, which we call as say a and b, now we see that the area which is under the curve but above x-axis and between these two vertical limits, that is between x equal to a and b, whatever is the area, alright, we are interested to find out what is that area. So this is what is called as area under the curve, and that is the starting point of the definite integrals. So moving ahead, we will see the different methods of how to calculate these areas, and we will also see the what is called as the fundamental theorem of calculus that gives us the simple way to calculate definite integrals. Right? Now one clarification in this regard, that is, although we say that it's area under a curve, it need not be physically below the curve, because it may happen that sometimes the curve itself may be going below x-axis. Now here if you see, for some part the curve is above x-axis, whereas for the some part curve is going below x-axis. So in this case, what do we do? That is, suppose we want to find the area between the two mentioned points, say between a and b. Okay. So here the area for the first piece that is lying above the x-axis will look like this, whereas the other area is below the x-axis. Right? So we have to calculate the two areas separately and add them. That gives us the total required area. Now let's move ahead and see the two important methods that we use to calculate the definite integrals.